Assalamu alaikum, student. In today class, I am telling you the some important question of AS chemistry. AS chemistry practical paper is near, inshallah, on 30th April or 31st. Solve these question with me. I am telling you the total base of the question. These are difficult if you don't know how to solve because there is a difficult solution of these one. But when you know about the solution, formulas are easy, but understanding is difficult. Okay. Now I am telling you this type of question coming in exam. Okay. Every year coming an important question. If you learn one question completely, then you can solve easily the every question. Okay. Now, in this question here is given acid donate H plus ion in aqueous solution. The number of the moles of H plus donate per mole acid is the uh, proticity of the acid. Mean acid giving the H plus ion in the solution. This is the proticity of the acid. For example, sulfuric acid is diprotic because H2 present, diprotic. Uh, as it donate 2 moles of H plus per mole because in H2SO4 when we see the formula there is H2 ions present. That's why we say this is diprotic. And normally every acid, mainly strong acid containing the proticity hydrogen ion concentration present in it. In this experiment, you will carry out titration to determine the policy proticity of the citric acid. No, there is a citric acid present, and citric acid also containing the H plus ion, which is showing the proticity of the acid. Okay. Now there is a FB1 compound. What is the FB1 compound? Uh, in equation, citric acid containing 7.5 uh, 0 gram per cubic decimeter. Now, FB1 is the citric acid concentration. Okay. Note everything carefully because this, when you note down carefully, then you can solve. FB1 is a compound given. This compound is citric acid. This compound, proticity present in this because every acid containing the H plus ion and the proticity present in the every solution. FB1 is acetic acid, and in acetic acid, what is the percentage of the concentration of the citric acid? It is not in mole, it is in gram per cubic meter, 7.5. Okay, we must change this one into moles. 7.5 gram per cubic decimeter given the concentration of the citric acid. This is the FB1 compound. Secondly, the compound is FB2, aqueous sodium hydroxide, 4 point. Concentration of the aqueous sodium hydroxide also given in this. Concentration of the aqueous, which is FB2. Must note down which compound is FB1. If you know about the compound, then you can solve easily the every question. FB2 is a sodium hydroxide. And in sodium hydroxide, the concentration given, what is the concentration of the sodium? First, the citric acid concentration, FB1. The second is the FB2, uh, sodium hydroxide concentration, given 4.5 gram per cubic decimeter. 4.5 gram per cubic decimeter. Now, this is the concentration of sodium, 4.5 gram per cubic decimeter. And the next is the FB3, which is thymopethylene indicator. Okay. Now this is the FB3, thymopethylene. It is indicator. FB3 is thymopethylene given. Must note down like that. Okay. When you note down, then you can solve easily. Otherwise, there is need to read paper in every part when you are not writing the every value. Now he's saying fill the burette with FB2. How we perform the practical? You have a burette apparatus with a stand. Okay, stand, clamp stand. In this, you keep a burette. This is the burette. There is a tap in burette. With this tap, you there is a opening wall on the tap. With this tap, you pour the solution into a conical flask. There is a conical flask inside the burette. This conical flask. First, he is saying in burette there is a solution given in the burette. What is the solution given in the burette? No, he is saying in the burette, the solution you poured, fill the burette FB2. FB2, what is? Sodium hydroxide. To check here, also you written here, sodium hydroxide. You fill the burette with sodium hydroxide. On the burette, there is a reading mark. Okay. On the burette, the reading is mark. When you poured the solution from burette to the conical flask, you when you pouring that there is a change form in the reading from the on burette. Burette mention the values. Burette may be of the volume of 50 cubic centimeter and 100 cubic centimeter. Maybe this type of volume in the burette we can adjust easily. And there is a no. What is the solution in burette? It is FB2. What is the FB2? It is sodium hydroxide. We put the solution of the FB2 in burette. And secondly, what is pipette of 25 FB1 conical flask? With the help of pipette, we put the solution of 25 cubic centimeter FB1. What is the FB1? Citric acid. It means acid is now in the conical flask with the help of pipette. Now there is a pipette of 25 cubic centimeter. Okay. Pipette shape like that. I am drawing here. Now this is the pipette. It is a small instrument and only 25 cubic centimeter volume can come in it. It is maybe of 10 or maybe of 25 cubic centimeter. Now there he is saying use a 25 cubic centimeter pipette. Pipette like there is a bulb inside in the mid of the pipette. And this pipette you fill at least 25 cubic centimeter of citric acid, which is FB1. Citric acid is FB1. You fill 25 cubic centimeter here of citric acid and pour this solution into the uh, conical flask with the help of pipette. Pour this solution in conical flask. This is the citric acid solution. Okay, this is the citric acid solution in the conical flask, and also pour 2 drop or 3 drop of the phenol thymopathaline also poured in the. Now add a few drop of the FB3 in the conical flask, FB3 thymopathaline in the conical flask, and citric acid in the conical flask, and sodium hydroxide in the burette. Uh, we use this one, okay? FB2 sodium hydroxide in the burette, and in conical flask, citric acid, and in pipette, citric acid. We fill first pipette, then we put in to the uh, conical flask. Now he is saying uh, the titration is no rough title here. Use a reading for titration. Titration, how you do the titration? You mix this NaOH into the conical flask, and there is thymopathaline, and thymopathaline drop present when you are mixing the uh, sodium hydroxide from the burette to the uh, conical flask, and there is a thymopethylene present, and thymopethylene is an indicator. And when you are mixing, what's happen? Uh, Thymopethylene is an indicator. Thymopethylene giving the color, okay? Giving the color in the solution when it is in acid or when it is in uh, alkaline solution. Thymopethylene indicator. What is the work of the uh, thymopethylene? When there is a reaction formed between the sodium hydroxide and HCl, then there is a color change formed. This color change tell us the uh, no compounds are neutral. Okay, when we put the thymopethylene in the acid, citric acid, what happens? There is no color, no color. Thymopethylene giving no color in the acid. When we poured uh, NaOH in it, no, it is reacting, and we also stirring the solution, and we put a little volume into the volume of the NaOH into the uh, conical flask, which there is acid and thymopethylene present. Thymopethylene showing no color in acid. When base is mixing, now what's happened when base mixing and there is a titration form? Basically, color appears blue color. When alkalinity of the solution increasing, now there is a blue color form, and you stirrer and also checking the conical flask and mixing the color. Basically, the color disappear. When a reading comes, when there is a titration form, what what's happen? Light blue color you see. It will not disappear. It's mean now both compounds are reacting with each other, and acidity and basicity finished. Now the compounds are neutral. Now check what is the reading coming is burette. For example, it is initially at 0 and you are mixing, then for example 22, 21 or 18, like this reading coming 21, 22 cubic centimeter, you write it here, okay? Now carry out many accurate titration. Now there is need to do 2 or 3 time titration. Now how we do? We change the liquid citric acid every time and put the thymopethylene in it, and then again we uh, mix the FB2 solution and in it, and then again we check the reading. Then 2 or 3 reading, we 3 reading at least we take care. Uh, every time we wash the um, beaker, conical flask and mix the thymopethylene, then check the reading. Now these reading are coming. From your titration, calculate the available mean. For example, there are 3 mean reading coming, just like at first 21 coming, secondly 22 coming, thirdly like 20 coming. Then you add these 3 reading and divide it by 3, you get the average. This is the average volume of 25 cubic centimeter FBN require dash cubic centimeter of the. Now this is the volume of the NaOH which you are mixing in the 25 cubic centimeter of FB1 present in the conical flask, and you are mixing. Now NaOH reading coming here, and you note down it what is the volume coming, average volume coming. You add these 3 and then divide by 3. Now check what is coming. This is a supposed reading, okay? I'm not doing performing here the practical. This is a supposed reading. Now 63 divided by 3. Now 21 coming, okay? Now it's mean your reading is here 21 cubic centimeter. It's mean 25 cubic centimeter of citric acid require 21 cubic centimeter of NaH for neutralization. Nextly, for each test, you should record all observation. We record the observation with the help of color change, okay? Color change is seen. The formation thymopethylene, I told you, colorless in acid. Then after that, change into blue. when you are mixing the base in excess of the reagents added, the formation of any gas, the formation of any precipitate and the solubility where appropriate in an excess of reagent, we also add in further tests. Now there is a where no change in color, you should write no change. And when there is a change, after these, we do many other tests. I will tell you about these tests. These are the tests which are coming in last. First, we calculate the reading from the titration set. Okay. Now, this is the we solve here A part and B part. Now I'm coming towards the C part. Experiment 2 in the determination of the enthalpy change delta H to the reaction of the 1 mole of the solid citric acid with aqueous sodium hydroxide. In this experiment, aqueous sodium hydroxide uh, AFB6, aqueous sodium hydroxide FB6. Okay, now when aqueous sodium hydroxide we prepare, this is FB6. Support to set up second cup in the beaker. Okay, support the second cup in the beaker. Add 4.825 gram of the FB5 to the cup. Uh, now he's saying add FB5 in the cup. Now check what is the FB5. He's saying here experiment 2 enthalpy change delta at the reaction of the 1 mole of the solid citric acid with aqueous sodium oxide. In this experiment, aqueous sodium hydroxide, when the sodium hydroxide in water, this is the FB6. Okay. Now support the second cup in the beaker, add 4.25 gram of FB5 to the cup, record your weight. Uh, First you weight the cup. When you weight the cup, then after that you put the NaOH solution in. Now FB5 solution, okay? FB5. Now check where is the FB. FB6 is the sodium hydroxide, okay? Now this is the fifth page, okay? Now after first page, we solve the second page. This is the second, then we solve third. Where is the third? No, there is the third page, okay? First we solve this one. FB5 is after these two page, okay? Calculate the amount and mole of the citric acid, 25 cubic centimeter of FB1 shown in your answer. Now, what is the mole of the citric acid? You check in start FB1 concentration is given in the question. You check there is concentration given. FB1 concentration given 7.50 gram per cubic decimeter. Okay. First, you change this concentration into moles. It is given 7.5 gram per cubic decimeter. First, you change this 7.5 gram per cubic decimeter into mole. How we change? You divide 7.5 with the total mass of NaOH. What is the total mass of NaOH? With the help of periodic table, you calculate the NaOH total mass. Na is 23, O is 16. When you check the periodic table, you find these masses. Na 23, O 16, H1. Then add what is coming 23 plus 17, it is 40. You divide here 7.5 with 40. When you divide it by 40, you get the moles per cubic decimeter concentration. Now 7.5 divided by 40. Now what is the concentration coming? 0.1875. 0.1875 concentration coming. Now when we divide it by 40, gram per cubic decimeter change into mole 0.18. What is coming? 0.1875. Now this is not change in mole. When it is change in mole per cubic decimeter, now you can find mole easily. Use your titration volume here uh, for citric acid. What volume you are using in the titration of the citric acid? You are using the 25 cubic decimeter of the citric acid. So 25 cubic centimeter it is. Change this one into cubic decimeter. How we change? 25 divided by 1000. If volume given in cubic centimeter, you change it by 1000. Then you get the reading in the cubic decimeter. Now 25 divided by 1000. When you divide it by 1000, now this is your volume coming in the cubic decimeter 0.025. Now these two reading we use to calculate the moles. Okay, you multiply by concentration of the citric acid by the volume of the citric acid, you get the uh, moles of the citric acid. Okay, now I'm solving here. Check how the moles coming. 0.025 multiply by 0.1875. Now you get here the moles 4.68, 4.68 into 10 power minus 3. These are the moles of the citric acid. Now, nextly, what is the step? Okay, these calculation. If you know about this calculation, then you can solve. When the concentration given gram, change into mole. How you change mole? Check the compound and divide the compound mass by compound mass. This given concentration, then it will be in mole. Then mole per cubic decimeter you multiply by cubic decimeter volume. If volume is in cubic centimeter, change the cubic centimeter into decimeter. Then multiply. Then you get the reading. Calculate the amount in mole of the sodium hydroxide in. Also saying the calculate the amount of sodium hydroxide in mole. You check what is the concentration given of the sodium hydroxide. It is 4.50. What is the concentration here? 4.50. It is also in gram. No, sorry. In above calculation, we not using the 40 because above calculation is the uh, concentration. Here we are finding is the this is the citric acid. Okay, we here use the weight of citric acid, not sodium hydroxide. Now change this one. There is we use the mass of citric because this is the calculation belong to citric acid. Okay. Now what weight also citric acid. What is the formula for citric acid? It is C6H8O7. C6H8O7. It's been 12 into 6 carbon plus hydrogen 8 into 1, then plus oxygen 16 into 7. Now total it. Okay, this is the citric acid mass. There is citric acid amount. That's why we are not using here 40. We use here the citric acid weight. 40 is for sodium hydroxide. Okay, now I'm correcting it. Okay, now what is the total mass of the citric acid? Calculate here. 12 multiplied by 6 plus in citric acid, there is a hydrogen, 8 hydrogen. It's mean 8 mass of the hydrogen. Then plus how many oxygen? 7. Then 7 into 16. Now what is coming? 192. Divide here by 190. 192 coming. When you divide 7.58 by 192, now you get concentration 7 point 7 point, what was the 7.58? Divided by citric acid mass. What was the citric acid mass? It is 190. Now there is concentration change into for citric acid into mole per cubic decimeter. 0.039. Okay. Now when we are solving for citric acid, we get 0.493. When we divide it by 192, it will be changed into the concentration change into 0.0394 0.0395. 0.0395. Now it will be changed into mole per cubic decimeter. And okay, student, clear what is the mistake in this? This will be remain same because we are putting the citric acid in the pipette, and pipette volume will be same 25, 0.01. Now multiply this volume and this concentration. Now check what is coming when we multiply. 0.07535. 0.075 25 multiply by 395. 0.025 multiply by 0.0395. 395 is the concentration and 0.025 is the volume. When we multiply volume and concentration, now we get the reading in mole 9.87. Here, all the things are accurate, okay? 9.87. 9.87 into 10 power minus 4. All the things are here accurate. There is no supposition in citric acid. Now the citric acid concentration is coming 9.875. Clear? Now here we get the citric acid reading. Now I am coming towards the next part of the solution. The next part of the solution there is given uh, calculate the amount of mole in sodium hydroxide. Anyone tell me on comment site how we calculate the uh, moles of the FB2. FB2 is sodium hydroxide, okay? You check what is the concentration of sodium hydroxide given. It is given 4.50, okay? Now write 4.50 sodium hydroxide concentration. 4.50. It is 4.50. It is gram per cubic decimeter, okay? Now change it into moles. 4.5 divided by 40. Because we find here, also we found here the mass of the sodium hydroxide, it is 40, okay? When you do this solution, then the sodium hydroxide concentration change into mole per cubic decimeter. Now this is second calculation of the uh, question. First, we change the concentration into mole of the citric acid. Then secondly, we change here the concentration of the sodium hydroxide into mole because there is a need to in question change into mole. 4.5 divided by 40. This is your concentration. Now the concentration comes 0.1125. Okay, student. If there is any problem, then you can ask on comment side. 0.1125. This is the concentration in mole of the sodium hydroxide. Now we change this concentration in mole. Now there is similar formula we use. Concentration multiplied by the volume. Now what is the concentration here? 0.1125. Multiply it by the volume of sodium hydroxide, which is coming in titration. For example, it is 23 coming. We multiply it. When you do titration, this volume you get and 0. It is not mentioned in the questions. This volume you get with the help of titration when you do titration. Now the 2.58. Now also change 23 into cubic decimeter. 23 divided by 1000. Because volume is in cubic centimeter, you are changing into decimeter. This is necessary. 0.025 multiply by 0.1125. Now what is coming? The Here moles 2.58 into 10 power 2.58 into 10 power minus 3. These are the moles. Okay. Now you get here the moles of sodium hydroxide and moles of the uh, this type of solutions coming in every paper. Okay. If you here get complete knowledge of solution this part, it's mean you solve all the papers. Okay. Now next, citric acid is triprotic uh, acid. Show whether you result in this experiment support this uh, uh, solution. How we say the citric acid? I told you about the condition when there is a one hydrogen concentration. Two, there is just like in diatropic in the H2SO4. How we say citric acid is triprotic? Mean the concentration of the hydrogen uh, higher. Okay, just like in sulfuric acid, uh, the concentration given uh, in sulfuric acid, the hydrogen ion concentration is H2. Okay. When we are coming towards the tripartite solution means the concentration of hydrogen ion is higher. Okay. When we divide the concentration uh, of H ion in the citric acid, three type of hydrogen ion release. Okay. Now I am telling you how the three type of hydrogen ion release. Just like H3 and the citric acid. H3 ions present. Okay. When we dissolve into the aqueous, now H plus ion and the H2 ion remain with the citric acid. When we further divide H2 citric acid ion in aqueous solution, then we again get the H plus ion in the citric acid and then H ion and the citric acid form. Then we again dissolve this H ion citric acid in the water. Then in aqueous, we get again H plus ion in the citric acid. Now, finally, the citric acid and H plus ion. It's been three hydrogen ion present. When one hydrogen ion present, just like in nitric acid and HCl, one hydrogen ion present. Now, this is the monotropic. Uh, uh, it is known as the monoprotic acid. When we dissolve the HCl in water, we get only H plus ion. It is monoprotic. When we dissolve the H2SO4 in the aqueous, we get the hydrogen 2 ion concentration. It is uh, diatropic. And when we dissolve the acetic acid in the uh, solution, we get three hydrogen ions. It's mean this is the triprotic. Now, clear, student? What is the triprotic? Now, complete the equation of the reaction with citric acid with sodium hydroxide. What is the reaction form when, no, this is the neutralization reaction, okay? Neutralization reaction, what's happened? The acid reacting with the base and forming a salt and water. Now, there is a equation given, acetic acid reacting with the uh, sodium hydroxide, okay? uh, it's been acid reacting with the alkalis. Acid reacting with alkalis. When acid reacting with alkalis, what is formed? There is a uh, there is a reaction form and acid neutralized by alkali. This is a normal reaction. Acid neutralized by the alkali. When citric acid reacting with the sodium hydroxide, there is a neutralization reaction form. When neutralization reaction form, what's happened? Uh, when the neutralization reaction form, acetic acid reacting with the sodium hydroxide and forming a salt. What is the salt here form? Sodium citrate. What is the salt form here? Sodium citrate. This is the salt is Na2, sodium citrate salt form, Na2C6, and H3, H5O7. Now this salt form. And plus, uh, when there is a water form. Now this is a neutralization reaction. Uh, Acetic acid reacting with sodium hydroxide, sodium citrate salt, and the H2O water is formed. This is the main reaction. Now, what is the formula of sodium citrate? It is, there is a low space, Na2C6, H5, and O7. This type of salt form. Okay. And basically, the acetic acid is aqueous, sodium hydroxide is aqueous, salt is aqueous, water is liquid. Now this is form. Okay. These are the state symbols of the reaction. Then again, there is a acetic acid do not contain a chiral carbon atom. Draw a possible structure from the molecule of the uh, uh, citric acid. Now he's saying the citric acid structure with chiral molecule. You don't know about the chiral molecule is a having the central atom. Okay. Uh, Now, what is the chiral molecule and the citric acid? Now, I am telling you how the chiral structure is formed in the citric acid. The citric acid chiral structure is like that. H C double O A C H and CH2. Now there is a chiral center here at C, OH, C double OH, and CH3 and C double OH. You check both side acetate molecules, and there is a chiral center present between these, which is COHCOH2. Both sided there is no chiral center present at the middle. Basically, the chiral center form when there is a four different groups attached on a same side. Okay. Here is the chances of the chiral center in the center. These are not the chiral center. Here you check carbon is only affiliated with the two different groups. When carbon is attached with the two different groups, then there is, we say, the possibility of the chiral center is not formed. Okay, because here carbon is attaching with two groups, COA and COOH. Now, this is the chiral center basically in every type of compound, but we check the chiral center which is containing the three different group. Okay, group 1, group 2 attached with the carbon. But there is only two groups attached. When we draw the structure, we check. It's mean acetic acid is not containing the chiral center. Secondly, the part D, a student uses the pipette label 25 plus minus 0.06 FB1. The student suggests that more accurate to measure the volume of FB1 with burette instead of a pipette. Instead, whether the student suggestion correct uh, in the answer. No, what is given here? There is given, we are finding the possibility. Uh, what is the possibility we find? Student was uses the pipette label 25 plus 0.06 to measure FB1. FB1 mean FB1 was the sodium hydroxide. I'm checking. Here I wrote also FB1. What is the FB1? No, this is the acetic acid. Okay. Now he's saying he's measuring the acetic acid with the help of reading 25 plus minus 0.06. And for this, he uses pipette label. In pipette, there is a label reading is 25 plus minus uh, 0.06, FB1. Then he is saying when the FB1 uh, with there is a uh, absolute value is also given, just like 0.06 also given, and in the question 0.06 absolute reading also given. But he's saying when he is using a burette instead of the pipette, okay, the student suggests that it is more accurate to measure the volume of FB1 with burette instead of pipette. Why? There is a accuracy form. Why there is a accuracy form when there is we are taking the reading with the burette. In pipette, there is a absolute value also given, uh, 0.06. Now, this absolute value also uh, providing a difficulty to calculate the precise value, to accurate value. Okay, because this value bring the solution towards the uh, precise value. Okay, this value bring the solution uh, giving the precise value 25 plus minus 0.02. The student suggests that more accurate to measure the volume of everyone with burette instead of the pipette. Now, when there is a precise value given 0.06, it's mean this value bring the reading accurately. Okay, this precise value, which is very small precision in the value, uh, giving the accurate reading. But when we are taking reading from the burette, there is no precisions. Now, how we calculate the accurate? No, we cannot calculate the accurate reading with burette because in burette there is no absolute value present. It's mean student is not correct. He is telling the precise value coming, uh, accurate value coming from the burette because there is burette no absolute value like 0.06. Here he using this pipette and pipette there is a small absolute value given. This means this absolute value uh, bring the result toward the accuracy. Now this is the first question solution. Practice this solution at home. It is very important for the exam, and when you solve completely and understand completely, you get complete marks in this type of. Tomorrow class, inshallah, I will solve the second question. Okay. Subscribe my channel and get more videos and get A-star marks in your exams and check the whole solution. If there is any problem, then on comment side or on my WhatsApp number you contact.